So these states are super important when you're writing a timed robot program. Timed robots are probably not what we'll be doing when we write competition code, but they are a good starting position, and they're really good for writing quick little test programs. So that being said, there is one other thing I do want to point out here, and it's these guys, these robot periodics and robot init. So autonomous init happens when you start autonomous, every time you start autonomous. Disabled init when you start disabled every time. When does robot init happen?
When you start up your robot, turn on the robot.
Specifically when you turn on the robot. So, what are things you would need to initialize when you turn on the robot? The motors, the sensors, controls, all that stuff you can do in robot init. Now, when autonomous starts, you can reinitialize them as you need to. Same for teleop. But when you want to create them, you'll do that in robot init. Okay. So the next thing we're going to look at is a handy tool called simulation. Because I don't have a robot at my house. I've got a lot of robot hardware at my house. Let's see, could I put it together? I've got enough, I think, to put a robot together at my house. But I don't have like one robot that is fully functional. So, and I would argue probably most of you don't either. So, it's hard to test your code as you write them, right? Right, yeah. So, not everybody has the capability to run robot programs on hardware. So a couple of years ago, WPI-Lib introduced simulation, and it is a super useful tool. So this robot has nothing it can do in it right now, right? We're going to simulate it anyway. If you click on your WPI-Lib button, and if you type in the word SIM for sim, you can simulate the robot code. So go ahead and do that. And it takes a little bit, but then you'll get a pop-up. Okay. And right now, just SimGUI is good enough. You click OK, and it finishes. And it will launch this window. Yep. One of the things with FRC programming is it does rely very heavily on networking, computer networking. There's a lot of network traffic involved over the process. But, all right, was everybody able to get this window open? So this is the simulation interface. It is kind of busy, and there's a lot going on, but it has a lot of handy stuff on it. For example, you can actually use your keyboard as a joystick if you just drag this keyboard 0 over to joystick 0, things like that. So you can read on here at the very top here, we're in disconnected, we don't have a robot. We're connected, but it's in the disabled state. We're connected, but it's autonomous. We're connected, but it's teleoperated. We're connected, but it's test. So you can actually change the robot state over here in the simulation. You can simulate being attached to the FMS, the field management system, how the robots will be at competition. You got this thing here called network tables. You can look at all the data being published to and read from the network tables. You've also got network tables down here, which this is the one that tells you what the data is. This tells you what's connected. If you go into this hardware menu, you can turn on a bunch of other things. We don't have anything in our code, so it's going to be pretty boring. But you can get the addressable LEDs, digital input-output, PWMs, power distributions, all kinds of stuff in this simulation window. But it's pretty boring right now because there's nothing to see. Any questions about that?
Would this connect to your robot, or would it like simulate a robot on the screen?
Neither. Well, I think the latter. So when you're seeing this, you are not connected to a robot. You are running the robot on your computer. So it's basically a way for you to read values and see, okay, is this going the direction I would expect?
It's telling you fictional motor values. The motor is rotated at fictionally motor.
Yeah, so if you wrote a program to say, hey, move the motor forward when I push the joystick forward, and you were to test that on here, you would be able to see which way is the motor turning based on the number it puts out. And if that's the right direction, you'll know. Or if you have two motors, it'll tell you, hey, are they going the same direction or opposite directions? So it's a way to test code without having hardware, but it's still kind of hard to see exactly what's happening.
Always knowing to figure out which way is forward with the motors.
Yeah, it's positive, right?
So this is the way that we will test the robot if we don't have access to the robot.
This is the most effective way to test code if you don't have the robot in front of you. Yep.
Most of the time when you're testing a robot, you'll be in the building.
So we're gonna close this window and we're gonna launch simulation again, but we're gonna do it a little bit differently this time. You're gonna go to the WPI Lib icon again. You're gonna simulate robot code again. But this time, when you get that pop-up with SimGUI, we're also gonna check use real driver station. Now, when the sim window pops up, you have one more thing you need to do. We're going to minimize all those, and we're going to open FRC driver station. All right, so if we look at your driver station, if you look right here where it says team number, I bet yours says XXYY. In FRC, I'm going to switch over to the iPad for this one to talk about real quick. Everything is on a network, and there's a very critical network. And so let's talk about what's on the network real quick. We've got the Robo Rio. That's the central processor that runs code. We've got the radio on the robot. That's what lets the robot connect to a laptop. We've got the laptop running a driver station, which communicates wirelessly with the radio. Maybe you've got another device hooked up to the radio called a Limelight. It's a device that lets you process vision, right? All of this stuff is happening on a wired and wireless network. But it's a very important network, and that network is based on your team number. Your wireless network is 10.te.am.x. Right? This is your wired and wireless network. And every team's looks like this. It depends on what your team number is. What is your team number? 538. And so in order to make that, we split it here. The 5 goes here, the 38 goes here. So that for 538, their network is 10.5.38.x, all those values. Another team like team 10101, right? Theirs would split here and get 10.101.01.x. And so this happens, and so the Robo Rio gets 0.2 for that X value. The radio gets 0.1. The driver station probably gets 0.5. The Limelight usually gets like 0.11 for its first one. But they're all on this 10.5.38. something. Your robot code knows what it's on because when you made the project, you told it your team number. But your driver station doesn't know your team number because you just installed it recently. To fix that, you go to the cogwheel and you type your team number in here. And when you do type in your team number, all three of these red lights, 2 of them should turn green if you're running the simulation. So the nice thing here, the first time we looked at simulation, when we were just looking at this, you probably need to use your keyboard or something to that effect. You can use other controllers, but you're largely just using the keyboard. This way, you can actually see what the driver station looks like when things happen. So if you put things in your dashboard view, you can see that as they change. So you don't always need to launch driver station to do simulation, but sometimes it will give you some useful results. All right, any questions about launching the simulation? Again, you don't always need driver station, but sometimes it's helpful. So I'm going to close driver station. I'm done with it. Exit driver station. And when you do that, sometimes the dashboard will close, sometimes it won't. I haven't figured out the rhyme or reason there.